Okay, so yesterday was 6.3, day 1 of logs and log functions. So we've got our warm up here. 2 to the power of x equals 4. Let's change them both to base 2. Well, this one is base 2. So that's 2 to the x equals 2 squared. Okay, if you think of it like that, the only reason I do that here, hopefully most of you didn't do that. You just said x is 2. Okay, the only reason I did that was to point out, remember we just set our powers equal to each other. Okay, so x equals 2. Okay, that's going to come in handy when we get down to some of these other ones. 8 to what power is 1? 0, so x equals 0. Okay, 2/3 to what power is 8/27? Yeah, 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. Remember, you have to raise them both to the same power there. In this case, it works out that it's 3. And then we get down to, say, like number 4. Well, this is base 4. This is 1/4. Remember, this is like having 4 to the first power, but since it's in fraction form, that would be a -1. Okay? That makes your fraction 1/4. And so changing your base, kind of like we did on number 1, is very helpful on, it's a little more helpful on number 5. If you're struggling with this, you could change this to base 2. So you get 2 squared is the same thing as 4. And then you can say, well, 2 to the power of x is equal to 2. Excuse me, is equal to 1. And then you get x is equal to 1/2. Thank you for pointing out the error of my ways there. Okay. Now, I'm hoping that eventually you just know that that's 1/2 power, not because it's half of it. Okay, but it's the 1/2 power. I'm hoping that we'll eventually get to that point if you're not already there. Okay, and then it's very helpful on number 4 to go that route. You could say, or number 6, excuse me. You could say that's base 2. So that 4 becomes 2 squared. And this 1/2 is base 2, and 2 to the negative first, bless you. You get 2x equals -1, so x is -1/2. Okay? Any questions there? Really quick review of yesterday. All right. Yesterday we went through our packet of problems. We did example 1. Okay. We went through those. We did example 2 and went through those answers. And then we did example 3 and went through those solutions as well. So just a quick review. I want you to remind your neighbor how to change log into an exponent and an exponent into a log. Explain the process there. Example 1 and 2. Everyone's focused back up here, please. Hey, any question on the first page from yesterday? What we did? Any misconceptions or anything that you were like, man, I got home and I just really didn't understand what we're doing on? Yeah, Emily. Okay. Oh, yes, this says 1/2 down here. Yes. Okay, let's go ahead and move on to page 2. How many of you were able, within your half-hour time, to finish the entire packet? How many of you were able to finish most of it, maybe got stuck in a few spots? How many of you broke the rules and spent more than a half hour? Well done. How many of you broke the rules and only spent 29 minutes?
Actually, I got no doubt that I probably did that.
Unbelievable. All right. Well, here we go. Number 4. Number 4 says evaluate log 8 using a calculator and the natural log of 0.3 using a calculator. Now, let me explain what we talked about, just a quick reminder from yesterday. So if you're looking at example 4, log 8. Oh, one other thing. How many of you actually went to the textbook? to reference some of this. Okay? Now remember, example 4, this is like cut right out of the textbook. Like I didn't actually go into a text and start clipping. But, I mean, this is the exact problem in there. Okay? So, just to remember, log, if there is not a base shown, it is base 10. So that, another way of thinking of that is log base 10 of 8. You won't see that, but that's what that means. Okay? Which means if you were to put that into your calculator, you should have got 0.903. Okay, so on a graphing calculator, base 10, you could be using this button right here. Okay, so you would end up going, you hit log, and then you put in, what was it, 8? Okay, I always close my parentheses and there we got it. All right, now part B is ln. ln is the natural log. Log naturel, French way. Okay, it's the natural log. The natural log is the log of the natural number. What is the natural number? E. So really, ln is the same thing as log base E. They mean the same thing. Okay? We just call it the natural log because it's cool. All right? That's probably not why. Okay? So, ln. Now, there is a special button on your calculator that says ln. So if you push ln, it gives you that. And then you put in 0.3 and you get that. Negative 1.204. All right. Okay, so two things you just learned, or at least one reviewed, and if you didn't look up what natural log means, then you just learned that. Make sure you make a note of it. Those are the two special logs that have their own little format. Okay, 1 through 12. Go ahead and tell your neighbor what you got on those problems. Compare your answers. Describe any struggles. Okay. Can I have your attention back up here? Please. What are questions that we have? 1 through 12. Actually, let's start 1 through 4. Any questions? Okay, let me go ahead and put up the answers for 1 through 4 just so you can see them, and then we'll see if there are any questions. Make sure number 1 was 3 to the 4th is 81, 2, 7 to the 1st, 7. 3, 14 to the 0 is 1, and 4, 1/2 to the negative 5th is 32. Make sure you put parentheses around that, otherwise you're just raising the top to the negative 5th. Okay, yes?
Could we have changed the 1/2 to 2 and then put it to the 5th?
You know what, if we're going from this form to that form, I prefer you leave it as 1/2. Yeah. Her question was, could you change this to 2 and just say it's to the 5th? And since they wrote it like this and you're going from log to exponential, I'd prefer you leave it like that. Okay, any questions on the next 4, 5 through 8? Okay, number 5 was log base 7 of 49 is 2. Number 6, log base 50 of 1 is 0. Number 7, log base 4 of 1/4. Make sure you put your parentheses, just good habit, equals negative 1. And number 8, log base 256 of 2 equals 8. If you are a bubbly writer, for all you bubbliers out there, okay, it's this. Okay, I do not, that looks like log of 2,562, log base 10. Make sure what is subscript is subscript. Okay, in fact, mine, what reminded me of that is mine is a little too high for my own standard. I would expect it down there. So if you are bubbly, or you're like, man, I really don't like anything having to be in the basement, it makes me feel bad. Sorry, man. Okay? Get used to it. Make sure that that thing down there is down by the bottom of the G. Okay? Gee whiz. Any questions on 9 through 12? Now that you know how to do them?
Wait, how does it work? 11.
Number 11? So number 11 you have to use a calculator on. Because base 10. You guys, the two that you shouldn't have had to use a calculator on are 9 and 10. What I do when I look at these, because I've dealt with them for a while, I know that if I write this in exponential form for number 9, it's going to be, if I were to set this part equal to x, this would actually be 2 to the power of x equals 32. So really that's just 5. Okay, so what I do is I just look at these two numbers, say 2 to what power is 32? And that's 5. And I look at this, 27 to what power is 3? Well, I know that it's not going to be a power greater than 1, right? I'm going to have to go downward on that. That one's a 1/3 power. Okay, 3 to the 3rd is 27, so if we go the other way, 27 to the 1/3 is 3. Make sense? The other thing you could do is you could just set it equal to x. You could say 27 to the x equals 3. Remember, go make that into base 3. That's 3 to the 3rd is equal to 3 to the 1st. So 3x equals 1. So x equals 1/3. This one you'd have to put on your calculator. Do you need me to show you how to do that? Yes? You push log, and then you push 12. And then you hit enter. There we go. We got it. All right. 1.079 and negative 0.288. Yep. Any questions on example 5? Go ahead and tell your neighbor what you got for example 5. How you did it? Okay, wrap up conversation, please. Here's what I'm going to tell you. I'm going to tell you you're going to see a lot of different patterns and a lot of different shortcuts. And mathematically, there are ways to show these things, which is what I will do. And then I will tell you how I actually approach it when I'm doing the problem. So there's two different things. There's one of conceptual understanding, knowing why something works. That way, when you go up to your friend, you say, hey, the answer's 4. And they go, how? You can explain. You know how it works, and you can apply that to tougher problems. Walsh, quit talking. Okay? And then there's me just being able to say, hey, the answer's 4. Why? I don't know. It's just 4. Okay? So making sure that you understand maybe the shortcuts, but also conceptually how it works. Okay? So when I look at this, I look at it as saying 10 log 4 equals x. And mathematically, the way you can go about this is an exponential form right now. Even though there's a log up here, the log is in the exponent position. So what we're going to do is we're going to rewrite this. If we can't solve it in exponential, rewrite it as a log, which means my base 10 moves over. I now have log base 10 of x is equal to log of 4. Well, if log, okay, let me pause there. You understand what he did?
They both have the base of 10, right?
Correct. The 10 moved over. We're going from exponential to logarithmic form. Okay, so let me do this. Let's pretend this isn't log 4 for a minute. Let's give it a happy face. It's 10 to the happy face power. That makes us all happy. Okay? We good? So over here, we can make in our key, we could say happy face equals log 4. That way we don't forget. All right? 10 to the happy face power equals x. So let's write it exponentially. When we do that, that would just mean happy face is equal to log base 10 of x. Yes, Emily?
So by moving the 10 over, how do you get a log?
just like we did up on these problems, right? So, excuse me, these. Where if you're writing it going from exponential to log form, you're just moving your base over and calling that 2 equals log base 7 of 49. You're just writing it in a different form. Okay? Yeah, this is a key concept here. Being able to go from one form to the other, because that really helps you to solve these. So these are good questions. Once I get it to log form, we can't use the happy face anymore. I'm sorry. I know, it's pretty sad. We have to go back to log 4. We can still be happy. Okay? But log 4 equals log x. Now they're both base 10. So if log base 10 of 4 is equal to log base 10 of x, what does x have to be? It has to be 4. When you have the same base and you're taking log of both, you can just drop those and figure out what x is that way. Now me, if I'm doing this problem, I'm looking at it and going, yeah, that's 4. Why? Because I know all this stuff. That's where you need to get to. I don't expect you to know all that stuff right now. There are special rules that you can memorize. The reality is, I would prefer that you understand why it works rather than trying to memorize that rule. And then eventually you'll just go, yeah, that's 4. You look at this and you go, well, 25 is really 5 squared, so that's 2x. Okay? Yeah?
So on the log 4 side, is the log, is the 4 the base of the log, or is it like a log?
This 4, right here, or this 4. This one, this is saying log. They're saying what is the log of 4? That means log base 10 of 4. Yeah. Okay, let's set this one equal to. This time I'm going to have to make it y because there's an x right there. Okay, so log base 5 of 25x. By the way, I wouldn't put x equals 4 here. I'd end up with the end result of just saying 4. Because really in the original problem there is no x, right? So, but anyway, we go here. This 25 to the power of x. 25 is, actually, let's leave it like that for a minute. It's in log form. You may not know how to do it, especially because there's a power and you have all this stuff. So let's move that over. Let's write it exponentially. 25 to the power of x is equal to, our base is 5, to that power. Okay, so once again, we're getting rid of the log by moving it over, which makes it exponential. Okay, 25 is what power of 5? 2. So that is 5 squared equals, so that now says 2x equals y. If 2x equals y, well, that's what we're solving for. Y is 2x. This thing up here that we're trying to solve is equal to 2x. Kind of, since they're the same base, you just deal with the exponents. We know that if this is going to be equal to that, since their bases are the same, their exponents have to be equal. Right? The only parts that are different are the exponents. So you say exponent equals exponent. Okay? All right, questions there? All right, everyone rate themselves 1 to 5 on those two things right there. So it's okay not to be perfect at that right now. All right? All right. Hey, let's move on to example 6. Go ahead and tell your neighbor what you got on example 6, how far you made it.
Letter B.
All right, wrap it up. Hey, you guys remember inverse means you solve for y or excuse me, you solve for x and then switch x and y, or switch x and y and then solve for y, however you want to go about it. Here's my inverse. Let's focus in on part A. Okay. So inverse, I made f of x equal y. And so y equals 6x here. I then solve for x, because the textbook likes to do that. And then I switched x and y at the end. And since it's f of x, the right format then is at the end, rather than saying y equals, it's to say g of x usually, or h of x, another something of x. You don't, if it's in function notation, end in function notation. That's proper format. Okay? Now remember, these are inverses. Tell your neighbor what the graphs will look like then.
They will reflect over x equals y, and the y equals x.
Yeah, there'll be reflections over y equals x. Okay, any questions on part A? Yeah?
Wait, how do you get the log 6?
Log base 6, I moved this over. I went from exponential to log form. So when you move the 6 over and out, it becomes log base 6. Yep. So if you have something being raised to a power of x, and you move it over, it becomes a log with that base. Okay, that's why we spent so much time kind of practicing that yesterday. Okay, part B. Don't let the natural log confuse you too much. You're taking the natural log of this whole thing, so you've got to move it over. Now, when you move natural log over, that's like, remember, natural log is log base e. So when I move it over, I get e as my base. So when I undo the natural log and bring it over here, that's base e. So e to the power of y equals x plus 3. From there, we have to subtract 3 and then switch our x and y values. And since it started as y equals, the end could be y equals. Yeah?
When you brought over the log e, and then the log, and then you just get rid of the log, it becomes e.
Mm-hmm. Yep. Okay, questions on them? Yeah, Aaron? E to the y, because y is right here. So when I move that over, what was over here becomes my power. Okay. Matt?
So, I was trying to do it. It was like comparing it to A, and since I just found out, I just did it. Like, since I just found out that log natural or whatever, log e. So since log 6 of x would then be f of x equals 6 to the x power, wouldn't y to the log e do the exact same thing? Or is it just because since there's a plus 3 in that parentheses that you have to get rid of it?
Yeah, you have to get rid of that 3 afterwards because this is locked inside. You're taking the natural log of this whole thing. So it's if the parentheses weren't here, then you would move it, or excuse me, you move the 3 first. Okay? And then take the natural log, or log base e of it. Okay? All right, tell your neighbor how you did on the next set there, 13 through 18. Okay, actually, before we do that, how many finished those? Okay, I want everyone working on them right now then. Okay, can I have your attention up here? Hey, everyone's eyes and ears up here. How many finished number 8? Number 13. Sorry, I saw a lot of 8s. Okay, what's the answer? So the answer is? Okay, so there's no y, so the answer would just be just x, right? I think y equals x. You put the y in, right? Okay. Hey, I understand what if you're thinking y equals x, but since we're inputting the x, I want you to actually I want you at the end to ignore the y. Or excuse me, since we're inputting the y, ignore the y at the end. So our answer is x. Okay? You guys, look. If you look at the problem, how many of you looked at that and just thought, well, I think the answer might be x? Okay? How many of you looked at it and are like, I have no idea what to do? Okay, so where you need to go and the note you need to make yourself on this page is, if I am in a format that I do not recognize, I need to change it to the other format. And if there's not an equal sign, set it equal to a variable. And since we already have x here, set it equal to y. This is exponential format. Tell your neighbor why this is exponential form and not log form.
So it's to a power. What you said was correct too. Sorry, kind of cut you off.
You've got to be kidding me with the focus on this. There we go.
Nope.
Okay, why is it exponential and not log?
It's raised to a
Abby. Good, because the log is in the exponent position. Okay? So when I pull, this is base 8. When I move this over, that becomes log base 8 of y, and I have log base 8 of x. So by writing it in log form, moving this part over there, that allows me then to pull this piece, the stuff that's in the exponent. To get that out of the exponent, we have to write it in log form. Another way to think about it is, if your variable is in the exponent position, you're going to have to write it in log form to solve. If your variable's in the exponent, you're going to have to write it in log form to solve. That's why we have logs. Okay, so log base 8 of x equals log base 8 of y. That means since this part, log base 8, is the same as this part, log base 8, then that has to be the same as that. So x must equal y. So my solution here is x. Yeah?
So when I'm solving it, I'm thinking of it more as just I label each part as like the base, the x, and the y, and then I just totally rearrange them according to which form I'm using. Does that keep working?
Yeah.
Okay.
Yep. Okay. Number 14. What'd you guys get? Matt? Might be. Is that what you got? You got negative 3x, negative 1/3, anything else? Okay, let's check them out. There's number 14. The answer is negative 3x. Now, you'll notice in both of these, negative 3x was right there. The x for number 13 was right there. Okay. You'll start seeing different patterns, but what ends up happening, since you have log base 7 of 7 to the negative 3x, one of the properties you're going to learn, in fact, after we learn the properties of log, you will not solve it this way anymore. You will rewrite this in a different format, and you'll go, hey, that part just gives me 1. Log base 7 of 7, this chunk right here equals 1. And that is your answer, negative 3x. That's because that base and the thing match, yes. Because the base and the 7 match. There's a thing called a power property that you'll learn with logs, and it says that anytime you have something in the exponent position, when you're taking the log of it, you can move that piece out in front of the log. That'll be something we go through later, which actually moves that negative 3x out in front here. So you end up with 1 times negative 3x. But anyway, the way we've learned it right now, write it as an exponent, 7 to the power of y, by moving that over. Okay? And then you have 7 to the negative 3x, so negative 3x equals y. Okay? Number 15. Tell your neighbor what you got.
Number 15. What did you got?
I almost got what you got.
I got 6x.
Answer on number 15 is 6x. Okay, so once again, set it equal to y. It's written as a log. You have the x in the power position, so write it as an exponent. Move this piece over. So that gives you 2 to the power of y equals 64 to the power of x. 64 is base 2. It's 2 to the 6th. So 2 to the 6 times x equals 2 to the y. So that means 6x must equal y, since your bases are the same. So you get 6x. Questions there? Are they kind of confusing? How many are starting to get them?
A little bit.
Okay.
A little bit.
Let's try number 16. Tell your neighbor what you got.
I didn't do that one.
Let me give you a really quick rule. Here's a shortcut. Anytime you see E and ln next to each other, it is 1. What's my answer?
1.
What's left?
20.
20. Not
No.
21. Okay?
No. Do not
Yes,
bring
so
that
the
back.
same thing. So, you guys, what ends up happening here, this part right here, we write as a log. So when we bring E over, it becomes the natural log. So you have the natural log of y equals the natural log of 20. So 20 equals y. So this equals 20 there. The shortcut is just to look at this and go, yeah, that's 1. Okay? No, it works the other way as well. This is why it works, though. Okay, just like on number 14. This part, log base 7 of 7 is 1. There's your answer. It's kind of the same idea. Okay? What was the answer on this one? It was x. We have 8, and we have log base 8. Kind of like having a 1. That is not mathematically accurate. You're just going, well, that's 1, so my answer is x. Okay, that's mathematically what's happening is this. I'm just describing the shortcuts on it. Okay? The inverse, number 17, should have been log base 4 of x. Y equals log base 4 of x. And number 18, y equals e to the x plus 5. Okay. Any questions? Okay, last piece. Go ahead and turn your paper over, please. Number 7. Okay, if we're graphing these, here's how I'm going to explain how to graph one of these, and then I'm going to be done with it for today. Too much talking, and too much talking for me. So the way I like to graph these, the book will do this differently. The way I like to graph them, I like to set up my table of values, and I like to pick values for y and solve for x. I kind of do it backwards. When I'm graphing a log, I pick values for y and I solve for x. Okay? So the first thing I'd have to do, if I am going to use that format, I would want to write it in a form that I am used to. So I am very familiar with exponential form. So I am going to rewrite this. Notice all I did was change f of x to y. I am going to rewrite this log in exponential form. Tell your neighbor what that would be in exponential form.
3 to the y. X equals 3 to the y.
Okay, so if I move this over to the other side, it is 3 to the y equals x. Now, does everyone see why I pick values for y and solve for x? Okay? Because in this format, you guys, I probably do it because I learned it that way in high school. Okay? But 3 to the power of y is, when I put 0 in, I get 1. So x is 1. Okay, and then that's all right. Okay? And when I put when I put 1 in, 3 to the power of 1 is 3. I put 2 in, I get 9. It's kind of backwards, so you have to kind of train your mind. Negative 1 would give me 1/3, and negative 2 would 1/9. Okay? So now if I'm drawing my grid, everyone go ahead and draw your grid and graph them. Plot your points. While you're doing that, I'm going to be handing out your assignment, but okay? Draw your grid and graph them. All right. Guys, here's the problem with doing it this way, and you really, really need to pay attention now, even if you think you did it right. Because my guess from experience in doing it this way and watching students do it this way, half of you got it wrong. Just by plotting it wrong. Some of you caught yourselves. When I am plotting 1, 0, I am actually let's start up here. I am plotting 1/9, -2. I'm going -2 on y and 1/9 on x. That's right there. Ish. 1/3 -1. -1 on y, 1/3 on x-ish. 1, 0. 3, 1. And 9, 2. Your graph should look like this. Now, if you have it flipped over, and it looks like a growth graph that's doing something like that, you graphed it backwards. Anyone want to volunteer if they graphed it backwards?
Mr. McCoy?
Yeah.
Basically, I graphed it backwards first so I could reflect the
Yes,
points.
that's good. You guys, now, I will tell you this textbook actually has you, what the textbook has you do is graph the inverse of this. They have you graph the inverse of it and then reflect it. That's how they explain it. That's up to you. I'm fine with whichever way you want, but the end result needs to be this graph. Okay, for those of you who did the other ones last night, they should look like this. I will leave them up there if you wanted to practice them. Okay, except for number 21, since I never finished graphing it. I will. Okay, and you have your assignment. Please let me know if you have any questions. No, you're not. Come on. I started graphing it. What happened? Must have got interrupted. All right, there we go. Finish that one.